Hello student, good morning. I am Dr. Sinha, Professor of Chemistry. Today I am going to discuss Faraday's law of electrolysis. Faraday's law of electrolysis. Last class I have discussed electrolytic cell. Now I am going to discuss Faraday's law of electrolysis. After extensive investigation on electrolysis of solutions and melts of electrolytes, Faraday published his results during 1833-34 in the form of two facts, two law. Okay, that law actually is called Faraday's law. What are that two laws? That law actually is called Faraday's law. What is that Faraday's law of electrolysis? Actually, this law has been given after extensive, you can say, investigation on electrolysis of solutions and it melts. First law of Faraday's I am telling you. First law, the amount of chemical reaction which occurs at any electrode during electrolysis by a current is proportional to the quantity of electricity passed through the electrolyte, means solution or melt. Here you have to understand this law, first law, the amount of chemical reaction which occurs at any electrode during electrolysis by a current is proportional to the quantity of electricity passed through the electrolytes. Okay, here electrolytes means solution or melt. Okay, then you know that in electrolytic cell, after passing the reaction, only reaction takes place. If you will not pass the electron, if you will not pass the current, then there will be no reaction. Okay, current is essential. If you will not pass the current, then there will be no reaction. Then how much reaction will take place? That depends upon how much current you have passed. Okay, on electrode, reaction takes place at electrode. Then how much current you have passed, that is responsible for quantity of reactions. Okay, then in that you can say sense, this how much reaction will take place means the amount of chemical reaction which occurs at any electrode during electrolysis by a current is proportional to the quantity of electricity passed through the electrolyte. Okay, that current is important, means quantity of chemical reaction is directly proportional to the current. Okay, current which is passed through the electrolyte. That if more current you have passed, then more reaction will take place. Means quantity of chemical reaction is proportional to the quantity of electricity passed through the electrolyte. Okay, this is the first law. Second law, the amount of different substances liberated by the same quantity of electricity passed through the electrolytic solution are proportional to their chemical equivalent weights. Chemical equivalent weight means chemical equivalent weight means atomic mass of metal divided by number of electrons required to reduce the cation. Okay, means atomic mass divided by atomic mass of the metal divided by number of electrons required to reduce the cation, because you know that cation will take the electron and it will convert to the metal, correct? Then per electron, you can say per electron atomic mass, that weight per electron, that is called chemical equivalent. Chemical equivalent means mass per electron, correct? This you remember, mass per electron, that is called chemical equivalent, and chemical equivalent is equal to atomic mass divided by number of electrons required to convert cation into metal or required by cation, that is called chemical equivalent. Then same current, suppose you have three cells are there, electrolytic cells, and in every electrolytic cell different type of electrolytes are there. Maybe in one maybe sodium chloride, other maybe potassium chloride, in third maybe magnesium chloride, fourth maybe calcium chloride, like that way. And same current if you will pass for the same time, if you will pass separately, then how much it will deposit? How you can say you will get the on cathode, how much you will get the this metal, how much it will deposit, different metal will deposit. As for example, NaCl, Na plus Cl minus, means Na will take the electron and convert into the sodium metal on cathode. And suppose in second you have taken potassium chloride as electrolyte, then you will get potassium on cathode. Suppose you have taken third, calcium chloride was there, then calcium will deposit on the cathode. And suppose on fourth Zn you have taken ZnSO4, then there Zn will deposit. Then this how much it is deposited, how much this metal, different metal deposited, then for that depends upon the chemical equivalent of that metal, which deposited. Okay, means the amounts of different substances liberated by the you can say same quantity of electricity passing through the electrolytic solution are proportional to their chemical equivalent weights. Okay, chemical equivalent weights, not like this these things ordinary weight. No, what is the chemical equivalent weight? Accordingly. Okay, there were no constant you can say current source. Okay, there were no constant current sources available during Faraday's time. When this research was done, that time there was no scope to pass the, you can say, current, constant current. It was variable, little variable. Okay. Then that time the general practice was to put a, you can say, colorimeter to colorimeter means it is a standard electrolytes, this is a standard electrolytic cell. What is the colorimeter? This is cell only, electrolytic cell. And this was used for determining the quantity of electricity passed from the amount of metal, amount of, generally it was silver or copper, deposited or consumed. By that amount, they were getting knowledge how much current was passed, how much quantity of electricity passed. That by the this how much silver deposited, silver or copper liberated or deposited, by that weight only. Then colorimeter is just like a cell. Now actually it is available, we can supply constant current, but that time it was difficult. Okay. And now it is not of use, it became obsolete. Obsolete means now it is not of use. Now we have constant current, that is the current is represented by I, constant current source available, and the quantity of electricity Q, capital Q, quantity of electricity is represented by Q, pass Q, that is the current. Then what is the value of Q? What is the value of Q? Means quantity of electricity passed through the electrolytes. Then that is equal to I into T. I means current and T means time. Okay, how much current you have passed in how much, up to what time? Maybe for 30 seconds, 30 minutes, 40 minutes, 1 hour, correct? Then current, how much current you are passing for 30 minutes? If both you are knowing current and time, suppose 10 ampere you have passed for 30 minutes, then you have to multiply this current and time, then total quantity you will get. Okay. Then Q generally it is measured in coulombs. Q is in coulombs. When you can tell Q in coulomb means I am talking about Q is in coulombs when I is in ampere and T is in second. Okay, ampere into second. If you will multiply, then you will get quantity of electricity will get in coulombs. Okay, coulomb is the unit of quantity of electricity, or electricity you can tell. The amount of electricity or charged required for oxidation or reduction depends on the stoichiometry of the electrode reaction. For example, Ag plus 1 electron, silver ion, cation, Ag plus 1 electron, it will give Ag, means solid metal you will get. Okay. 1 mole of electron is required for the reduction of 1 mole of silver ion. This is very, very important for calculation point of view. 1 mole of electron means how much? Avogadro number 6.02 into 10 to the power 23. Anything in that number is called mole. Then that is equal to 1 mole. Then 1 mole of electron is required for reduction of 1 mole of silver. 1 mole of silver. Okay. And we know that charge on one electron is equal to charge on one electron. Actually, I told you that electron has a charge. Each electron has a charge. Okay. Then what is the charge on electron? Always you remember, charge on one electron is equal to 1.6021 into 10 to the power minus 19 coulomb. Minus 19 coulomb. You always remember 1.6021 into 10 to the power minus 19 coulomb. That is generally it is represented by C. Coulomb means C. C is represented for coulomb. Then here one electron carry 1.6021 into 10 to the power minus 19 coulomb. One electron. Then Avogadro number of electron, how much? That is a 1 mole electron. Then one electron carries a 1.6021 into 10 to the power minus 19 coulomb. Then Avogadro number, how much? Avogadro number of electron, then multiply it. Then that is the Avogadro number into, Avogadro number is known as Na, capital N, capital A, small, down write a small a, capital A, N, or N simply write. A is written for Avogadro number, A, Na you can write, but A big capital letter, but in a small way you can write. Capital letter Na, down write A, N. Then just to multiply Avogadro number into this charge 1.6021 into 10 to the power minus 19. Then this charge, this is the total charge you will get by 1 mole of electron. Means 6.02 into 10 to the power 23 into 1.6021 into 10 to the power minus 19. Then you will get 96,487 coulomb per mole. Per mole electron means 96,487 coulomb. That we are telling generally 96,500 in round figure. Exact is 96,487 coulomb per mole. Okay, then now you understood how this figure has come. Then this coulomb means 96,487 coulomb per mole. That is called actually Faraday. This quantity of electricity is called Faraday, F-A-R-A-D-A-Y, and is represented by the symbol capital F. Capital F. Okay. Then now you understood how the value of capital F has come. One charge of one electron you remember and multiply by Avogadro number. Simply you will get 96,487. That is roughly in a round figure it is called 96,500. Okay. Now example I am telling you that suppose magnesium, suppose it is in solution, magnesium ion is in solution. Then magnesium has 2 plus, Mg 2 plus, then it will require 2 electron to convert into the magnesium solid. For reduction, it requires 2 electron, correct? Then it will convert Mg 2 plus 2 electron, it will convert into Mg solid or metal. Then here this 2 electron is required, and aluminum suppose it is there, then aluminum required 3. Suppose aluminum, I give an example, the sodium, maybe one cell of in that electrolyte is sodium chloride, other is potassium chloride. third one is magnesium chloride, fourth one suppose aluminum chloride is there, suppose. Then here if potassium is, if NaCl is there, then Na plus 1 electron, only 1 electron is required. In case of magnesium, 2 electron will be required. In case of aluminum, Al 3 plus, then 3 electron is required. Then 1 electrode, 1 mole charge on 1 electron, you are knowing. Charge only on only 1 electron, 1.6021 into 10 to the power minus 19. But for 1 mole it is 96,500 or 96,487 exactly, this coulomb. Then here this that 1 mole of magnesium, suppose it converted into this magnesium metal. 1 mole of magnesium and 1 mole of aluminum require 2 mole of electrons. Magnesium required 2 mole, or you can say how much a charge it will require, that I am telling you. Then 2 electron is required, magnesium 2 electron. Then 1 mole of magnesium, magnesium ion and 1 mole of aluminum requires 2 mole electrons, 2 mole electrons. Then 1 mole electron means 1 F. Then 2 mole electron means 2F. Hence magnesium requires 2F and aluminum required 3F. Correct? Because magnesium, 1 mole magnesium requires 2 mole of this electron. 2 mole electron means 2F. 1 mole electron means 1F. Correct? 1 mole electron means 1F. Then 2 mole electron means 2F. Then magnesium required 2F and aluminum required 3F electrons. Correct? And 1F means how much charge, you are knowing, 96,500. It means total number of charge required by magnesium 2 into F means 96,487, and for aluminum 3 into 96,487. This number of charges required. Okay, the charge passed through the electrolytic cell during electrolysis is equal to the produce of, equal to the, you can say, product of current in ampere and time in second. How much actually total charge is required? The charge passed through the electrolytic cell during electrolysis is equal to the product of current in ampere and time in seconds. And in a commercial, you can say, production, in commercial production of metals, current as high as 50,000 ampere are used. 50,000 ampere are used. That amounts to about 50,000 ampere means what? How much? Then it will come around 0.518 Faraday per second. Commercially, you can say, in a commercial production, of metals, current as high as 50,000 amperes are required. That means that amount about 0.518 Faraday per second. Correct? 50,000 ampere into 1 second. That is now converted into the charge, coulomb. 50,000 coulomb. correct? Then 50,000 coulomb means what? If you convert 96,487 coulomb, correct? Then this is why this thing per mole, this per mole 96,487 coulomb per mole. Here 50,000 coulomb is there. 50,000 coulomb means how many, you can say this things, quantity of current. 26,487 roughly you consider like 1 lakh. 96,487. Suppose roughly 1 lakh. Then here 50,000. 50,000 coulomb means how much? Half, roughly half. That is actually it is a half means here that is a 0.5, exactly 0.518 Faraday per second. Correct? Then this I have told you just for understanding purpose, exactly 50,000 ampere into 1 second. 1, that is the, now you got the quantity in coulomb. This is the it became coulomb, 50,000 into 1 second, coulomb. Then 50,000 means here half of the 96,487. Okay, because this charge 96,487 coulomb means 1 F. 1 is equal to 1 F. Then 50,000 means how much? 1 divided by 96,487 into upside 50,000. It will come around this 0.518 F. Okay. Then this I have discussed. Then 2 laws I told you. What is the 2 laws? Faraday's 2 laws. That question is asked and it is used in these things for solving the numericals. Then first law I told you that amount of chemical reaction, how much reaction will take place, okay, that is directly proportional to the quantity of electricity passed through the electrolyte, correct? On that current, amount of current passed through the electrolyte. This is the first law. And quantity, how it is determined? Quantity Q is equal to I into T. I means ampere into second. And second law, for if same current is passed for the same time in different cell, in different electrolytic cell, then you will get you can say amount deposited or metal deposited on electrode on each cell. That depends upon the chemical equivalent weight, okay, of that metal. This is the second law. These 2 laws I have discussed, correct? As for example, now sodium atomic mass is how much? Atomic number is 11 and for sodium it is 23. And 23 sodium required only 1 electron, 1 mole of electron, correct? Then here its chemical equivalent mass is 23 only, because 23 divided by 1. Now for calcium it is 40 atomic mass is 40. Then 40 it requires 2 electron. Then 40 divided by 2. Like that way you can calculate for magnesium also. Magnesium 24 it requires 2 electron. 2 mole electron you can tell. 2 mole means 2 electron first you tell only, then divided by 2. That in that ratio quantity deposited on each metal, on quantity of metal deposited on each cathode, you can tell, on each cathode, that depends upon their this thing, chemical equivalent. Okay, chemical equivalent. Now one a small numericals by I want to clear it. Question I am reading, that is easy actually. A solution of copper sulfate is electrolyzed for 10 minutes. For 10 minutes. Okay. With a current of 1.5 ampere. Then now ampere means they have given I value, they have given 1.5 ampere. Time is 10 minutes. You can convert into the second. The solution of copper sulfate is electrolyzed for 10 minutes with a current of 1.5 ampere. What is the mass of copper deposited at the cathode? Correct? By this numericals you can understand. Already I have briefed you. Now easily you can solve this numericals also. Easy numericals. Then here 10 minutes you convert into 10 minutes you convert into second. Okay. Then here this time is equal to how much? 660 into 10. That is a 600 second time. And charge, then total charge is equal to how much? Total charge, Q. Q is equal to I into T. Then I is equal to 1.5 ampere. And time is equal to 600. Then 1.5 into 1.5 into 600. That is the 900 coulomb. 900 coulomb. Correct? Then according to the reaction, copper sulfate is then a Cu++. It requires 2 electron. 2 electron. Then here 2 electron means here you are talking about 2 mole electron. Okay. Then Cu2 plus 2 electron. You will get copper. Means copper will deposit. Then how much it is required? 2 mole means 2F. 2 mole of current means 2F. 2F is required. Then here we require 2F means 2 into 96,487 coulomb. Then how much it will deposit? Then it will deposit 1 mole of copper. It will deposit 1 mole of copper. Then 1 mole of copper means what? 63 gram of copper. 63 is the molecular weight of copper. Okay. Then here you will get this thing, 2 mole. 2F means 2 into 96,487 coulomb. This is required to get 1 mole of copper, or you can tell 63 gram of copper. Okay. Then but you have only 900 coulomb. 900 coulomb. This is the standard rule. 2F is equal to 63 gram. 2F means 2 into 96,487 will deposit 63 gram of copper. 1 mole copper. Then for 900 coulomb, how much? 2 into 96,500 coulomb, you can tell roughly, will deposit 63 gram. Then you passed only 900 coulomb. Then how much? Then quickly you know that 63 divided by 2 into 96,487 and upside 900. Simple calculation. 2 into 96,487, that is equal to, means it will give 63 gram, then for 1 and then for 900 C coulomb. How much? Then it will come, it will be very easy. 63 divided by 63 upside 900, and this down you will write 2 into 96,487. correct? 63 into 900, upside and down in denominator, 2 into 96,487. Then you will get how much? 0.2938 gram. You will get 0.2938 gram of copper. Okay. Then this I told you, very easy to calculate. How much electron is required? That is F, you can tell. 2E. 2E means 2F. 2F. 1E means 1 mole. Then 2 means 2 mole. 2 mole. 2 mole of electron. Then 1 F, 1 mole electron means 1 F coulomb. 1 mole electron means 1 F coulomb. And 1 F coulomb means 96,500 or 487, you can tell. This you always remember. Then you will not face problem in solving the numericals. Now I am going ahead that products of electrolysis. Products of electrolysis, this concept is very, very important. Products of electrolysis depend on the nature of material being electrolyzed. What type of electrolytes are there? Accordingly, you will get the deposit. That type of metal it will deposit. And the other things also depends that electrodes, type of electrodes being used. Products of electrolysis depend on the nature of material being electrolyzed and the type of electrodes being used. These two things are very, very important. If the electrode is inert, as for example, platinum or gold. Platinum is inert, gold is also inert because it does not react. That's why it is called inert. It does not participate in the chemical reaction and acts only as source or sink for electrons. Means it will just because it will not take part in the reaction, it will just it will function as a sink for electrons. It will just like a conductor. It will take the electron and it will pass through it. Okay. Then this I told about the inert. On the other hand, if the electrode is reactive, then what we will do? If the electrode is reactive, then it will participate. If it is reactive, it participates in the electrode reaction. Thus, the products of electrolysis may be different for reactive and inert electrodes. Okay, both if the electrode will react, then product will be different from inert electrodes. The products of electrolytes depend on the different oxidizing and reducing species present in the electrolytic cell and their standard electrode potential. Okay, means what type of electrolytes you have taken. Then there in any electrolyte means cation and anion will be there. Then what type of cation is there, what type of anion is there. In that way we will get the product. If suppose you have taken magnesium chloride, then you will get magnesium. Magnesium will get on cathode and chloride is also there. Then you will get this chlorine gas also. Magnesium also will get, chlorine also will get, chlorine gas at anode you will get. Like that way, if NaCl is there, then already told you Na will get, sodium metal you will get, and chlorine gas at anode you will get. Calcium chloride is there, same way calcium will get on cathode, chlorine gas you will get on oxygen. then that depends upon the electrolyte. What type of electrolyte you have used. Okay. Then here this other things also, it depends upon electrode potentials. Electrode potential. Okay, every electrode has different potential. Then it depends upon the electrode potential also. Okay, if you will not get the desired electrode potential, then you will not get the product. To get the product, what is required potential in that quantity, in that requirement, in that required potential if is there, only then you will get the product. Otherwise you will not get the product. Okay. Then this sum of electrochemical process, although feasible, are so slow kinetically that at lower voltage these do not seems to take place, and extra potential has to be applied. This is what I told you, same things. Some of the electrochemical processes, actually that may be feasible, may take place, but they are very slow. Feasible means possibility is there, but may be very slow kinetically, that at a lower voltage. If voltage is lower, then this reaction will not take place. It requires extra voltage also, only then you will get this product. Despite reaction is possible, but it is so slow that at less voltage you will not get the product. Then extra voltage you have to pass, or it is required. That extra voltage or additional voltage, that is actually called over potential. Question is asked, what is the over potential? Over potential is the extra potential required to for the reaction to take place. Okay. Then this I have discussed, that electrochemical process, although feasible, are so slow kinetically that at lower voltage these do not seems to take place, and extra potential called over potential has to be applied, which makes such process more these things, if extra potential will not supply, this reaction will not take place. Extra potential is required, and if will not apply, then this reaction is difficult. This reaction will not take place. Okay. For example, if we use molten NaCl, that is also called melt, MELT. Molten is also called melt. Then for example, if we use molten NaCl, the products of electrolytes are sodium metal and chlorine gas. Hence, we have only one cation, sodium ion, which is reduced at the cathode, means Na plus 1 electron, it will give sodium metal at cathode, and one anion, we have one anion, that is Cl minus, which is oxidized at the anode, means Cl will lose the electron. Oxidize means it will lose the electron. Cl 1 minus is there. 1 minus means 1 electron it has, that it will lose. Then it will convert half Cl2. Okay, Cl 1 minus that will convert into half Cl2 plus 1 electron. Loss of electron is oxidation. Then this reaction will take place at anode. Correct? Cl minus, only one Cl minus is there. Then you will get half Cl2 plus 1 electron. If 2 Cl minus is there, then you will get Cl2, complete Cl2 plus 2 electron it will lose. Then like that way, during the electrolysis of aqueous sodium chloride solution, the products are, but here you have to understand many things you have to understand here, and all are important. Now I am telling you, during the electrolysis of aqueous sodium chloride means NaCl is dissolved in water. Then what product you will get? This theoretically I told you. You will get sodium metal and chlorine gas. Sodium metal you will get at cathode and chlorine gas you will get at anode. But in real practice what happens, that I am telling you. The products, during the electrolysis of aqueous sodium chloride solution, the products are NOH. Three products are there. The products are NOH, first product. Second is chlorine. And after that you will get hydrogen gas, H2. Three products you will get. NOH, first product. Cl2, second product. And H2, third product. Okay. In this case, what happens? Just to understand, question is asked. Okay. Here, we were thinking that it will give sodium metal and chlorine gas. But here you are not getting sodium metal. You are getting here NaOH. Cl2 anyhow you are getting, but sodium metal you are not getting. You are getting NaOH. You are getting chlorine gas and you are getting hydrogen gas. Okay. And here what happens, you have to understand why you are getting NaOH. Why you are getting NaOH, you have to understand. In aqueous solution, aqueous means water, then here you have in the solution, you don't have only Na and Cl, you have water also, H2O. Then now you can think what will happen. NaCl is there, H2O is also there. Then H2O will dissociate as H plus OH minus. H plus OH minus. Then now just it will go to the opposite charge. It can form NOH also. NaOH. Okay. You will get NaOH because Na plus OH minus is there. You will get NaOH also. First things, how NaOH is coming, now you have understood. Okay. And chlorine gas you will get, that is clear. Cl minus is there, you will get Cl2. Okay. And what will happen with hydrogen? Na, okay, Na and OH. Na is now used up with OH, NaOH is formed. Now what will happen to the hydrogen? Chlorine also is chloride ion converted into chlorine gas. Now alone who is hydrogen? Then hydrogen H plus, that after taking the electron it will form, reduction will take place, H plus plus one electron, half H2, that is at cathode hydrogen gas will form and at anode chlorine gas will form. If 2H is there, suppose, then 2H plus 2 electron, complete H2 gas it will form. Then now this you have understood that in aqueous solution, sodium metal you are not getting. You are getting three products: chlorine gas, hydrogen gas, chlorine at anode, hydrogen at cathode, and NOH in solution you will find. At the cathode you will get, here I am telling you with some values, reaction, why you will not get sodium in advance, IIT advance, or in other tough competition. This question is asked. In tough competition means explanation you have to give why. Okay. Then here just to see. Actually, I told you that it should give sodium metal, but it is not giving sodium metal. You are getting hydrogen gas. Why? For that explanation, you understand. Na means sodium plus 1 electron. It will give sodium metal. For that, you required, how much you required? You can say potential. Then you require minus 2.71 volt. Minus 2.71 volt you required for this process. And for hydrogen, if for hydrogen means H plus 1 electron means half H2. For this, it required 0 volt. 0 volt, you know, for standard hydrogen electrode potential, it is considered as a 0. Standard hydrogen electrode potential, its voltage 0. Then now, the reaction with higher value is preferred. This is the rule. Don't forget. Don't forget the reaction with higher value of E is preferred, and therefore the reaction at the cathode during electrolysis is hydrogen plus 1 electron half H2, because it is a 0. It is a 0. Then 0 is more than minus 2.71 volt. Minus 2.7 volt is less than 0. Less than 0. Then more voltage is preferred at cathode. Then hydrogen is 0 and sodium is less, minus 2.71 volt. That's why hydrogen gas is formed at cathode. Now you understood the answer why sodium is not depositing there. This is the explanation I told you. But again I am telling you, but hydrogen H plus aqueous is produced by the dissociation of H2O. That is, the H2O dissociates as H plus OH ion. Okay. Therefore, the net reaction at the electrode, you can write sum of, you can say what reaction? Then you can write this two reaction I told you. One reaction is H plus 1 electron, that is the half H2, and other reaction, that is the H2O, it breaks into H2O, that is the liquid, it breaks into H plus OH minus. Then both you can add that, then you will get, that is the reaction. Just to add both these two reaction, H plus 1 electron, that is the reduction. Okay, that you are getting half H2, and other reaction, that is H2O is giving H plus OH minus. This both reaction you add it, then you will get left side, you will get H2O, because H will cancelled out. H will cancelled out. Okay, then you will get H2O. Left side you will get only H2O plus electron. H2O plus electron left side, and right side you will get half H2 plus OH minus. OH minus you will get. Okay, this is the first two reaction you have added. Then you got this net you can say reaction you got. The net reaction at cathode, only cathode, not the cell, at cathode. Okay, because electron is going to be used at cathode, then H plus 1 electron. But H came from the H2O dissociation. That's why that is called reaction at the cathode. Then now reaction at cathode, now you have written H2O left side and right side H plus OH minus. Now OH minus is there and H plus is there. Then what will happen to H? You are knowing. H will at cathode, it will go as a H plus will come H2 gas, and OH minus, it will react with Na plus in solution, it will form NOH. Okay. Now you can see at the anode what reaction will take place. Always in a cell you consider two reaction, at anode, at cathode. At anode what reaction is going on, at cathode what reaction is going on. Okay. And for any cell, three things you have to consider: anode, cathode and electrolyte. What is the name of electrode? What is the name of cathode? What is the name of electrolyte? Okay. Whether it is aqueous or acidic or basic. If acid is present, then acidic solution, it is called acidic solution. If base is present, means OH, then that is called basic solution. If only water is present, then aqueous solution. Aqueous electrolytic solution, basic electrolytic solution, acidic electrolytic solution. If H plus is present, means acid is present in solution, then acidic. If base is present, like NOH, KOH, then it is called basic. And nothing is present, only water is present, then it is called aqueous. Then now at anode, what reaction will take place? Now you think. Then chloride ion at anode, it will release one electron and it will form half Cl2. Cl1 minus, it gives half Cl2 plus one electron. Okay, at anode. And other one more reaction will take place at anode. That is the H2O or 2H2O you can write. 2H2O, it will give O2 plus 4H plus 4 electron. You know that at anode oxidation takes place. Then here actually you are comparing, just like a cathode you have compared. Why not Na deposited like that way? Here oxygen gas is also forming during the reaction. During the reaction, oxygen gas is also forming. Chlorine gas is also forming. Then which gas, any one gas will form at anode? Any one, two gases are there. Both are claiming. Then which gas will form at anode? For that explanation now you understand. Okay. Then at anode, I told you that one reaction is possible, half Cl2 plus 1 electron. Chloride ion, it will form half Cl2 plus 1 electron. Same time, 2H2O, it will, if 2H2O will write, then O2 plus 4 hydrogen plus 4 electron, it will give. 2H2O, it will give oxygen gas plus 4 hydrogen ion plus 4 electron. Both near the anode, both reactions are taking place. Then for the chloride ion converting to chlorine gas, then that time it requires 1.36 volt. Okay, that time E standard is 1.36 volt, and for 2H2O, for this process standard E cell is 1.23 volt, less 1.234 volt, that is less than 1.36 volt. Then here what will happen, that value you keep in mind. For the chlorine, when it is forming chlorine gas, that time 1.36 volt, and when H2O is forming oxygen gas, that time it is 1.23 volt. Then here you have to understand the reaction at anode with lower value of E is preferred. See, at cathode situation was different, condition was different. At cathode, higher value of E was preferred. At cathode, higher value. But here, lower value is preferred. You remember, At cathode, higher value is preferred, but at anode, lower value is preferred. Okay. The reaction at anode with lower value of standard is preferred, and therefore water should get oxidized in preference of chloride ion. It should be I am talking about. But actually what happens finally, that also I should understand. Okay. The reaction at anode with lower value of E is preferred, and therefore water should get oxidized in presence of chloride. Should get. However, on account of over potential of oxygen, reaction that is for chloride I am talking about is preferred. Finally, chlorine gas is forming, because this oxygen gas is forming. Then on account of over potential of oxygen, because it required more potential, that this potential is not sufficient, 1.23 volt. Correct? That's why these things 1.36, this reaction required more potential. 2H2O plus O2 plus this to at anode to form oxygen gas. This if you will consider over potential of oxygen, then in that sense reaction means this chlorine, Cl converted into chlorine plus electron, that is preferred. Hence the net reaction on anode or at anode, you can write very easily that overall reaction for the cell you can tell. Then NaCl, you know that NaCl you have taken in water, the NaCl will break into the, in presence of water, Na plus chloride ion. This reaction will take place. After that, at cathode H2O, H2O plus 1 electron, it forms H2 gas plus OH minus. Okay, at cathode. And then at anode, Cl minus will convert into half Cl2 plus electron. Then all these three reaction you add it. Cathode reaction, anode reaction, you have to add extra things. NaCl aqueous solution, it breaks into Na plus chloride ion. This simple ionization, not reaction at anode and cathode. But if there is no sodium and chloride ion, then what reaction will take place? Hence you have to consider NaCl aqueous. So this NaCl will ionize this electrolyte as Na plus chloride ion. This also you have to consider, total 3. If you will add, then left side you will get NaCl plus H2O, NaCl plus H2O. Cl will be not there, because this Cl, Cl is present in both left side and right side. Okay, means NaCl that is giving Na plus chloride ion, and at cathode there is no question of Cl, only H2O is giving half H2 plus OH. But at anode, Cl minus is converting into Cl2 plus E, half Cl2 plus E, and Cl will be cancelled out. One Cl is in left side, other Cl is right side. For NaCl, that is giving, that is right side, and chloride ion is converting to chloride into the half Cl2 plus electron. That's why Cl will be cancelled. Hence, net cell reaction, left side you will get NaCl plus H2O, and right side you will get 4 product. What is that for the 4 product? Then that you will get Na plus OH ion plus half H2 plus half Cl2. Correct? Because Cl2 and H2 both are anode and cathode. Means after adding After adding all three reaction, then left side you will get net cell reaction, that is the NaCl plus H2O. Right side for product, right side, that is the Na plus OH minus plus half H2 plus half Cl2. Half H2 and half Cl2, you know, half H2 at cathode, half Cl2 at anode. Then this is the net cell reaction. Then over potential matters. Okay, if over potential was not required by for oxygen, then oxygen would have taken place. Correct? But due to over potential, if you take the account of over potential, then chlorine gas, for chlorine gas it is easy to react. That's why chlorine gas is forming, not the oxygen gas at anode. But in reaction, oxygen gas is forming. That's why in reaction, in total reaction, it is coming. Now another example I will give you related to this only, potential. The standard electrode potential are replaced by electrode potential. Standard potential, sometimes it is written as a only this electrode potential. Nernst equation, just they are considering like this only. Now here I want to tell you that standard electrode potentials are replaced by electrode potentials given by Nernst equation to take into account the concentration effect. What is the concentration effect? Again you listen. According to the Nernst equation, I am telling you that this concentration potential or concentration effect, you have to consider. The standard electrode potentials are replaced by electrode potentials given by Nernst equation to take place into account the concentration effect. Okay. Now I will tell you what is the concentration effect. Now what is this actually concentration effect? First only that you understand. Sometimes in a reaction, electrolytic cell, anode is there, cathode is there, electrolyte is there. Then near the anode and cathode reaction is going on. Reaction will take place. Then electrolytes will be everywhere. Electrolytes will be near the anode also, near the cathode also. Then what happens during the reaction? Solution which are near the anode, which are near the electrodes, you can tell, it will be used up. It will be used up. Means because these electrolytes are also only it is going to be used up. Then near the electrodes, any one electrode first to consider, that concentration will become less in comparison to the solution which is little far, little more distance. Suppose just solution is touching the electrode, and suppose after some distance, 1 centimeter, 2 centimeter, 3 centimeter, their solution has more concentration. Correct? Their solution is more concentration, and near the anode it became dilute. It became the dilute solution, but just little far, little. Their concentration, solution concentration is more. Then now you are, you can say, finding two types of concentration. Near the anode less, and little far it is more. Then now only in one solution you are getting two types of concentration. Only in one solution you are getting two types of solution. Suppose you are considering copper sulfate solution, copper in copper sulfate. Suppose that you are considering. Then in copper sulfate solution is there, but near the anode copper concentration is less. Solution near the anode copper concentration is less, but little far, up to 2 centimeter, 3 centimeter, their concentration is more. Then that only you can say in the same solution, two type of concentration is there. One is dilute concentration of copper sulfate, other is concentrated copper solution of copper sulfate. Correct? Then suppose near the anode C1 concentration is there of copper, so both are copper sulfate. Both are copper sulfate. C1 concentration of copper sulfate, another is C2 concentration of copper sulfate. Then it will form a cell. It will form a cell. That cell is called concentration cell. Because there is a change in concentration. Due to the change in concentration, they will produce a EMF, electromotive force, EMF, and this EMF is called back EMF because it is creating. Then now it will protest the main you can say what we are supplying current or volt. It will protest that against. That is called a back EMF. Back EMF. Then you have to consider this back EMF also. When a question of potential comes, then you have to consider this back EMF. Or effect is concentration effect. But due to this concentration differences, it is creating potential. Then that potential you have to take into account. Okay. Then this is actually called this is actually is called this things concentration potential. Concentration cell produces concentration potential. It produces potential. Okay. This you have to consider. I have told you about the back EMF. Now again you listen more. During the electrolysis of sulfuric acid, what reaction will take place? Then I am telling you. During the electrolysis of sulfuric acid, then this reaction at anode first to understand. Okay. First, that possible reaction at anode I am talking about 2H2O, because aqueous solution you have taken a sulfuric acid. Okay, the electrolysis of sulfuric acid. Electrolysis means now this H2SO4 will break okay, into hydrogen and sulfate ion. It will break. Then here 2H2O, because H2SO4 is present in water. Okay, then a possible reaction at anode I am talking about 2H2O. It will produce oxygen gas plus 4 hydrogen plus 4 electron. That you are knowing. Okay, and for this reaction 1.23 volt is required. This already you know, already discussed earlier. 2H2O, it gives oxygen, 1 mole oxygen plus 4 hydrogen plus 4 electron, and this electrode potential required is 1.23 volt. A standard electrode potential or a standard electrode potential also you can tell. 1.23 volt is required. Okay. Now again you can see important things here. And other reaction 2SO2 plus, only first understand that H2SO4 I told you that water, in that water will what will happen? You have to 2H2O, it is producing oxygen gas plus 4H plus 4 electron, and sulfate, how much sulfate? Suppose 2 molecules you are taking, then H2SO4, okay, then 2 mole is there, the 2 sulfate ion it will give, because 2H2O you are considering, 2H2O, okay, Then here now if 2 mole H2SO4 is required, there you have taken, then 2SO4 means you will get 2 H2SO4 means it will produce 2 sulfate ion. 2 sulfate ion it will produce. Then 2SO4 it will give H2O H2O8 because SO4 2SO4 is there. Then just to balance it will give S will become 2S 2SO4 means H2O8 H2O8 2 plus 2 minus H2O8 2 minus you will get, and it will release 2 electron because actually each sulfate ion has 2 negative. Then 2SO4 means 4 negative. But here what is happening that now H2O2 is holding only 2 negative and it is releasing only 2 electron. Then 2 to 4 electron compensated. H2O8 is having 2 electron out of 4 electron. 4 negative charge 2 they are having and 2 plus 2 electron. Then now it is you can say balance means 2SO4 2SO4 2 minus you can write H2O8 and 2 negative, that will be in solution aqueous plus 2 electron. And for this what will be the voltage? 1.96 volt 1.96 volt. Then here what you will find? For dilute sulfuric acid, listen here now, very means you are going to consider concentration effect. Then for dilute sulfuric acid, first reaction is preferred means 2H2O, it is giving O2 plus 4H plus 4 electron. Then if solution is dilute, then this reaction is considered at anode, means at anode this reaction will take place, means oxygen gas will evolve at anode if H2SO4 is dilute. And if reaction is concentrated, then at higher concentration of H2SO4, then now that is the second reaction in which 1.96 volt is required, that is preferred. Okay, because it is highly concentrated. Highly concentrated means what? That it can produce, it can make concentration cell. It will back EMF it will produce. Back EMF it will produce. Hence, to counter this back EMF, you require more voltage. Correct? Because now just like I told you, you are riding the bicycle and someone is pulling you from the back side. Then you will put more force. Same situation is there. Because now back EMF is there. Then to neutralize this EMF, you require from the outside more you can say volt. That's why at high concentration of H2SO4, you require, if it is there, then this reaction in which 1.96 volt is required. That was 1.23 with H2O. When H2O was reacting, then that time only 1.23 volt was required, less. But here H2SO4 concentration is high. Then there is a possibility that it can make concentration cell, back EMF will be produced, and that will work against the main voltage. That's why main voltage required will be more. Then in that situation, this second reaction 2SO4 2 minus, that will give H2O8 2 minus plus 2 electron. That reaction will take place. This question is also asked. also asked in examination, particularly advanced level or in higher examination, higher competitive examination, this question is asked. Okay. Then today, now I am stopping only here. Next class I will start batteries. Okay. Thank you.